We are on the section 12.2, page 58, arithmetic, sequences, and series. Okay, last time we talked about sequences and series. What are sequences? We are talking about a sequential event which follow a certain pattern. Okay, then the series is what? The sum of the sequence, right? Then today we are going to talk about arithmetic sequence. What are they? We were talking about the sequences, they follow in certain patterns. We do the basic one by what? Adding, subtracting to get next number, or by multiplying and dividing to get the next number, right? We do the simple sequence for now. Arithmetic sequences are this way, okay? So by adding and subtracting numbers, a fixed number to get to the next item, okay? So let's see. If we have 7, 10, 15, 19, 23, what do you think the next number will be? Because it's by what? Adding 4, right? So you'll expect next number to be 27. Then it's the difference, the distance from one number to the other will be what? Your second number minus 7, the first number, that would be 4. Or you can do the third number minus the second number. Every one, the difference between the next one would be positive 4, right? If we look at this, 8, 15, 22, 29, what do you think the next number would be? By what? Adding 7, right? So next number will be what? 7 plus 26, that 29 will be 36. So your number, the difference or distance would be what? 15 minus 8, that would be 7, right? Because the pattern by adding a number or subtracting a number, we call them what? Arithmetic sequences, right? If it's a 13, 10, 7, 4, 1, next number would be by minus 3 or by adding a negative 3, right? So next number would be negative 2. So for 1 minus 3, right? So your distance would be 13 minus 10. That would be 3. We call those our arithmetic sequences. By adding a number to get the next term, right? So let's do the formal definition. Formal definition is this way. You will answer this way. If we ask you, what are arithmetic sequences? You will say an arithmetic sequence progression is a sequence in which each term, after the first term, each term will obtained by what? Adding a constant number, right? The difference. And to get the next term. Then this difference, we call it common difference. So the D is what? The preceding number subtract the number before it, right? So the number, if the general term an, right? If we talk about this term, the next term will be what? An plus 1. The difficulty for this section you will have are all those symbols. You have to understand the subscript. Nth term means general. N plus 1 means what? The term after it. Or you say, okay, if this one is any term, then this one will be what? A term before it, right? The preceding term. So, let's see. Let's find out how do we find the general term. How should we find it? We need this formula. Okay, so we can predict, extrapolate to find the terms, nth term down the road, right? That's the formula we need to find. So let's look some examples first. Then we collect those thoughts, then put in here. Then we can just follow the formula later, right? Let's compare this way. If we have, say, 3, 10, 17, 24, right? So, what do you think the next number will be? By adding what? Adding 7. So this one will be 31, right? For this one. Last time we said, how do we write a general term? We were guessing, right? We say if it's by adding 7, we say, okay, every term will be multiplied of 7, right? Will be 7, 14, 21, so you will add a 7 each time. So we will multiply by 7, but we have to fit in the first one is 3, but the first one here is 7, so we minus 4. Then everything else will fall into place. Last time we did this, right? We were guessing. But now we will develop the formula, then we just follow the formula. It's much easier, okay? It will make more sense. So if we write a notation, first one will be A1, right? A1, A2, A3. And this one we'll call it the common difference. So we call it what? D. So next term would be add one more distance, A1 plus 7, right? And next one would be what? A1 plus 2D, right? This one you add twice that much difference. So let's compare them. If my A1 is 3, A2 is what? 10. 10 means what? You add one more 7, right? That would be 10. A3 would be what? A3 would be started from beginning. You add what? 2 of the 7, right? That would be 17. So if we do A10, that would mean what? How many 7 you have to add? Would be what? 9 of them, right? Because 9 distance away. So you 9 times 7. Is that right? So that would be 66. So if we write the regular symbol in general term, like this, A1 is A1, right? A2 will be what? A1 plus what? 1 distance away. A3 will be what? A1 plus 2 distance away, right? Then if you have A10, that would be A1 plus how many distance away? 9 distance away. Is that right? Then if we do A100, that would be what? 3 plus how many distance away? 99 of them, right? So that would be, you just add them up. If we write it in the general term, A100, that would be A1 plus what? How many distance away? 99 distance away. Okay, so if we use this thinking, AN will be what? 3 plus how many sevenths away? If nth position, right? 100 would be 99, 10 would be 9, 3 would be 2. So your distance will be one less position, right? It's like 1, 2, 3, 4, 5. So distance from 1 to 5 only add how many times? 4 times, right? Nth position, that would be what? N minus 1, right? So in general, we write AN equals what? A1 plus what? N, how many distance away? N minus 1 position away, right? So if we do this one, we simplify, would be 3 plus 7n minus 7. That would be 7n minus 4. Look at that. AN equals 7n minus 4 for this example. Is that the same as we guessed before? But formally, we get this way instead of guessing. Okay? So, in general, to write a general term, what will we do? We actually writing the formula is this way in general, right? AN would be what? Started from A1, then you need to have so many common distance away. How many distance away? N minus 1. Is that right? So for the sequence, we are talking about arithmetic sequence. We are talking about find the general term AN. We need what? Need A1, right? We need our distance. Then we need a position in, say, 100th day. How many, COVID-19 cases. Then we do what? That would be our AN, right? 100th day, that would be 100. Then we need all those to be able to predict, to find our AN. So we summarize all the arithmetic sequences with adding or subtracting number by a common difference. We will use this formula instead of guessing. It's much more reliable. Okay, so let's take a look next example. Let's see. We say, give you a sequence like this: -4, -3, 4, 11, 18, and 25, right? We want you to find the general term, AN. Okay, that means we want you to find the formula. Then we also want you to find the A45, 45th term. Instead you write 45 times. That will take forever, right? But with the formula, we can just plug in. So Then we need to identify our A1 and D. And N is general, right? So what's our A1? That's your first term. What's your D? What do you get? From first term to second, or from second to the third. So it will be 4 minus -3, that will be 7. That means you add a 7 for the following term, right? Then we want to find the AN, then N is what? General, right? Then AN, from this formula, it should be what? A1 plus N minus 1 and the D, right? A1 is a -3, then N minus 1 is the general right now, D is a 7. But you don't leave the answer that way because you need to simplify, spell it out. So that will be -3 plus 7n minus 7. That will be what? 7n minus 10. That will be your general term. What do we expect? Okay, then for the B, A45, what do we do? Which is the first term plus what? 45 distance away means 44. 45th position means 44 distance away, right? Times your D, that would be 7. Usually we put a parenthesis around D because just in case you have what? The D is a negative number, right? So we will do that way to take care of your negative sign. All right, so then you plug in, you will get number is 305 this way. Or you can plug in the number here, right? AN say AN is A45, it's this one. So you do 7 times 45 minus 10. You actually get a 305. They are the same. Got idea? Pretty straightforward, right? When you started. But when you add more formulas, you will mingle all of them, which is which. Then you try to find out. Then you have to, in your mind, make it clear what does A1 mean. A1 is the value for the first term. Then N is how many terms down the road, how many days down the road, right? And D is your common difference. Next one, if you have this, we want you to find the A50. So for your find the A50, what's your A1? 21, right? What is your D? The difference. 17 minus 21 is -4. Remember, it's negative. Okay, you need to make sure your signs are correct. So our N is 50th term, right? So we want to find what? A50. A50 will be what? A1 is 21 plus N minus 1. So 49 position away times your D, right? -4. So you plug in, your answer is, you just do your numbers, you will get the answer. Okay? So, what are we doing? We are doing what? The arithmetic sequences. Right? Then, that's the formula we need to use. Okay? So, let's see next example. So you have all these positions, A1 and AN general, right? And distance. So you need all this. Then we might give you what? mainly 3 numbers you are managing, right? We will give you 2 of them, expect you find the third one. Like we will give you the first position, then the common difference, then we will expect you find, say, 40th term or 50th term, then you will find the third number. We might give you a first number or give you a 10th term, then we will expect you to find a common difference, right? Or we can give you the common difference, we'll give you a 10th term, then we will expect you to be able to find the first one, how you started. All right, so if we give you this one, if we give you A11 is negative 62, A5 is what? Negative 104. That means we want you to find A20. What happened? You don't know A1, you don't know D. You need those 2 numbers to be able to predict the 20th, right? So you look this way. You don't know A1, A2, A3, A4, A5 is what? Here, right? A5 is negative 104. Right? Then it says you continue to go 5, 6, 7, 8, 9, 10, 11th is negative 62. Okay? Then we expect you to find what? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We want you to find this one. The whole point is what? You need to know what's the first one, right? You need to know first one. Then you need to know the D. You need to know how to get to the next one. Then you can predict just by the formula. So we need to know, what? We need A1, we need a D before we can to find A20, right? Without that, we cannot do it. How we are going to find the A1 and D? Look this way. But we do know A11 is a negative 64, A5 is negative 104, right? From here, we can have what? A11 equals what? Because 11 is predicted from A1 over there, right? So A11 is what? A1 plus how many positions away? 11 minus 1. So it will be what? 10 positions away with the D, right? That means A11 is A1 plus 10D, right? Then A11 is what? Negative 62 equals A1 plus 10D. That's what it's saying. Then for the second one, what do we have? A5. A5 is what? A1 plus 4D, right? 4 distance away. It means what? A5 is negative 104 is A1 plus 4D. Then at least we know that much, right? If I write it this way, A1 plus 10D is negative 62, then this one is A1 plus 4D equals negative 104. Right? You look at it, you say, so what? Where is my A1? Where is my D? Right? Because that's what we need to be able to predict A20. However, if I do this way, if I put a curly there, does that look familiar? It's like x plus 10y equals negative 62, x plus 4y equals negative 104. Does that look like that one? Similar? 2 by 2. That's in your 152B class. This class at the beginning, we did 3 by 3, right? Okay. Then how do we solve the system of equations, linear equation, actually, for this one? What do? We can use what? Either addition method or substitution method, right? Okay, so let's get rid of A1. So we multiply this by negative 1. Can we do that, right? A1 minus 4D equals 104. Then you will rewrite the first one, 10D equals negative 62. Then you put a curly there for the system of equation, right? Then what do? You add them, right? You have 60D equals, you add them equals 42, right? So our D is what? 7. Then what's your A1? So A1 would be, you plug in 7 times, so A1, so we do here, A1 plus 10 times 7, right, equals negative 62, right? You minus 70 on both sides. A1 would be what? Minus 132. So we got our A1 and D. So A1 is negative 132. Then D is 7. Then we ask you to find the A20. Can you do that? So your A20 would be what? Right? A1 plus how many distance away for 20th term? That would be 20 minus 1 times what? 7. Right? So that's positive, that's negative. You end up 1. That's how you do it. So for this portion, pretty much you have to use quite a bit of things you have learned before. Okay? You do need A1 and D to be able to predict every one of the term, each term, with the formula. Okay? If you don't have A1 and D, somehow you have to track back to find them. That's how you would do. Okay? So, look at the next one. You are given the first 3 terms of sequence. If the sequence is arithmetic, find the AN and D. Okay? We want you to practice find the what? Find AN and D. Right? So we'll give you 3 numbers, 8, 10, 16, and 28, 24. So is this arithmetic sequence? By adding what? 8, right? So your D would be what? Second term times minus first term, so that will be your D. Then we want you to write the patterns. General term means the patterns. Means what? A1 plus N1, N minus 1D. So your A1 is 8, right? Plus N minus 1. N is general. We didn't specify. So you just use N times 8 times your D. right? So you end up A plus AN minus 8. So your pattern is AN. See, N is 1, that's 8. N is 2, 16. N is 3, that's 24, right? So we're saying if you add 8, the general pattern is AN. If you add 7, general pattern will be what? 7N. You can even tell, even find it actually with the formula, right? Then you look at the next one. If it's 8, 16, 32, is this one arithmetic sequence? Add 8 is not 24. So actually it's times 2. So it's not arithmetic sequence. We do it next time, okay? So this is not an arithmetic sequence, okay? So look at the next one. If 54, 36, and 24, can we do it? This one, if it's a minus 18, this one is not minus 18, right? So actually this one is what? 36 divided by 54 is what? 2/3. Actually, it's multiply 2/3, multiply 2/3. Okay? It's not as subtracting, so we do it next time. For this one, we just do it what? Adding things. Okay? For next one, if we have 54, 36, 18, do we have arithmetic sequence? Let's see, minus 18, minus 18, yes. So our D would be what? 36 minus 54, it's minus 18, yes. Then general term will be this one, right? A1, 54, right? Plus general term, general is N minus 1 times the D is 18, right? So that would be 54 plus 18N minus 18. So your general term should be what? Oh, this one is what? That's how it will happen. Usually you will miss this, see, the negative, okay? So this one is positive, so 54 plus 18, it's 72. That would be your general term. Right? So what did we just do? We are doing a sequence. We call it what? The arithmetic sequence, right? Then using this formula. Okay, first you have to decide, is that so? Is the arithmetic sequence we are dealing with? First you have to identify them. Okay? Then we are going to do the series. So if we want to add all those numbers together, what will happen? Okay, so if we have this situation, say if you have 1 plus, sequence is 1, 2, 3 to all the way to 100. All right. Is this an arithmetic sequence? By adding 1. Right? So besides that, we find the sequence. We say, how about the sum? if you add them together. So there was a story when Gauss was a very famous mathematician, right? Was in grade school. Then, so a teacher tried to keep him busy because he was just way ahead of class. Then he was bored, and the teacher just asked him, okay, why don't you add this up? Find 1 plus 2 plus 3 all the way plus to 100. Add them up, right? They didn't have a computer at that time. That was 400 or 500 years ago. Give him a busy work. But it took him less than a minute to finish. How come? Right? Because he used his pattern recognition skill to resolve this much quicker way. Okay? So that's 100, that's 99, that's a 98. So he realized if he does 1 and 100, that would be what? 101, 2 and 99, 101. He realized the pattern. If the first one and last one added together, and second one to the second last one added together, then third, they all have the same answer, right? One to the last one pair up. If he does that, then how many things he pairs up? Total he pairs up, 1 to 100, total 100. So he has what? 50 pairs of what? 101. Is that right? Because first one to the last one. So what does he do? He just say, okay, 50 pairs of 101, that would be 50 times 101. So that will be the answer. Quickly he can finish, right? So the method is what? Your first term, right? You have 50 of them. Total is 100. So your pair, one to last, totally half of the 100, 50 pairs, right? So total 100 number, then you have 50 pairs, half of it. Then how do you get 100? First one and last one, 1 plus 101. 1 plus 100, that would be your 101. So you can get the answer this way. Okay? Then let's see how we will write a formula for the series. So for the sum, we use this notation, Sn. Okay? So we are on your page 60, right? That's the formula. So the sum up to how many? 100 terms. So n is your 100, right? So that will be half of it. So will be half of the total terms. 100 half is 50. Then you do what? The first one plus the last one. So that's how we find our total terms. Okay? We just let you see the examples and to develop this formula. So to find Sn, what do we need? To find Sn, that means we need what? You need the first term, right? And we need a what? The last term. And we need the n to be able to find the Sn, right? If you have an. Otherwise, we need a what? D to do that, to find the San this way. Okay? So in general, we need what? A1 and D and AN to get our SN. Is that right? Right? So far, we are learning the arithmetic sequence, right? We learned the finite sum. Then we learn the general term will be what? AN equals A1 n minus 1 times D, right? We also need all those things. One is the sequence, the general term. Another one is what? The sum. So we are learning arithmetic sequence, right? Then we find the general term AN. We also do the what? Finite sum, right? And finite sum means what? You add to 100 terms. Then if you do S infinity, means infinite. 1 plus 2 plus 3 plus forever. Can we find it? We can't. So this one doesn't exist, right? We start to see the formulas. There are many formulas you need to use. Then you need to figure out which is which and when you need it. Okay? So far, still simple. Let's take a look some more examples on your page 60. All right? It says find the series. Find the sum of the first 13 terms in -10 plus -6 plus -2 plus right? We need to find the first 13 terms. So we know the sequence is like this. -6, -2, all the way, right? To the 13. But for find the sum for S13, right? We need to do what? 13, n is 13 divided by 1, 2, right? A1 is what? -10 plus AN. Then AN, n is what? 13. So we need a what? 13 here. The thing is, for this sequence, do we know the 13? Not yet, right? We need the 13 to finish the sum. So we need to find A13. How can you find A13? You do have A1 is what? -10. Your D is what? -6 minus -10, which is 4, right? Add 4. You do have what? A1 and D, but we don't have a 13. Can we find it? Sure, because 13 is what? A1 plus what? N minus 1 times D, right? We do have A1 is -10. N is what? N is 13, right? So 13 minus 1 is 12. D is what? -10. The formula for the 13th term, right? So what do we have? Is minus, okay, let me make sure. So n is 13, 12 times what? D is, see, typo. D is 4. Double check, right? So what's our D? 4, right? 4 times 13th term, 12 positions away, 48 minus 10 would be 38. So did we find A13? Now we can plug back in to find the S13, right? So it's 12 divided by 2, negative 10 plus what? 38. So that would be, then you multiply them, that would be 128. Okay? So what we have is here, right? We find S13. We do have N. We have A1. Then you can find the AN. Then you find your 13th term. Then you can find your sum, right? If you didn't see this one, if we just give you this, negative 10 plus negative 6 plus negative 2 plus continue all the way to 38. By looking this sum, right, we ask you how many terms are there? We give you A1, which is what? Negative 10. D is what? You can find the difference, right? Which is what? 4, right? Then do we know the N? We don't know how many terms are there, right? But we do know AN, the last one is what? 38. So those go together. You have two formulas for the arithmetic sequence. Then one is the sum, one is AN. Which one you should use now? We are not asking you to add them together. We only ask you the N. Then you can use this formula, right? Because AN, you always rewrite it 1 plus N minus 1D, right? We have so many variables here. 1, 2, 3, 4, actually. We have 4 variables. But the third and fourth are together. So we do know AN, which is 38. A1 is negative 10. Do we know the N? No. N minus 1. Do we know the D? It's 4, right? When we plug in, we only have one variable missing. Linear equation. Can we resolve it? Find the N? Yes, right? 38 equals negative 10 plus 4N minus 4. Then 38 equals what? Negative 14 plus 4N. So you add a 14 on each side. That would be 52 equals 4N. Then N would be what? How many? Divided by 4. 13 terms. You have total 13 terms. You end up with 38 there. Okay? Next one. If you have this one. If first term is negative 10 and 13th term is 38, just like here, right? But if you didn't see this before we do this, then if we just tell you for the test, I will not give you all this. I just ask you this, if, right? First term is negative 10, 13th term is 38. Then what is your common difference? Which formula you should use? The general term or the series? It's general term, right? Because it's what? AN equals A1 plus N minus 1 and D, right? We want to find the D. Do we know the AN? AN, last term for the 13, right? When N is 13, A13 would be what? 38, right? So we have N and AN. We want to find the D. We do have A1. A1 is what? Negative 10, right? So we plug in this formula, A13. A13 is, so A13 is what? A1 plus 13 minus 1D. Is that right? Then what is your A13? A13 is 38. Do we know A1? Negative 10 plus 12D, right? If so, plus 10, 48 equals 12D. So what's your D? D is 4. That's how we find it. Okay? So that's how you use these two formulas. That's what you need to do, right? But you have to decide which formula you need to use. If, look at the next one, second example, if you have this, like this, what do we want you to do? We want you to find the sigma. Sigma means what? The sum, okay? Then 5k minus 2 is your general term. So what kind of sequence is that? We need to find it, right? We need to find this. So actually, you just plug in. Start from 2, 3, 4, all that, right? So when you plug in 2, 2 times 5 minus 2 is 8, right? Then second term, 3, k is 3, 3 minus 50, 5 times 5, 15 minus 2 is what? 13, right? The fourth term will be 18, this way. All the way to the 19th term, 19 times 5 is 95 minus 3 minus 2 is what? 93, all the way to 93. That's the sequence. Then we want you to do the sum. Sigma means you add them all up. How many total terms you have? So total terms will be how many? Not the 19, because 1 to 19 totally 19. From 2 to 19, right? This is the 19th term. It's 93. So actually you have what? Total is 18 terms. Okay? So if we wanted to do the sum on this one, what's your A1? That's your 8, right? We need A1. What's your D? You add what? 5. Right? What's your N? N is total term from 2nd to the 19, total 18 terms. Then what's your last term? That's your last term, right? Then we want to find the sum of how many terms? Actually, it's 18th term. So this one means this one, right? As 18. How do we plug in? Here. So n over 2, 18 over 2. A1 is 8 plus AN, right? It's 93. That's what you need to do to find this sigma. That's how it works. Then you do that, you find out it's 909. Got it? What you hear is kind of straightforward. It seems, right? You just follow through. But when you do it yourself, you will all mingle all these symbols, notations, which is which, you will get confused for some of you, right? So practice. Let's look at the next page, page 61. Let's see what they want us to do. Here says, a triangle display of cans in a grocery store has 32 cans in the first row. 32. They have triangle display, right? Then Second one will be what? 26 in a row, 20 cans in the third row, then doing that way. Find the general term, AN, and the number of cans in the fifth row. They want us to find it there, right? Find out how many cans they are in the display and how many cans are in the top row. If you do that, then what's on the top row? Say if you work for the grocery store, say Safeway, they want you to put the cans there one by one. Bottom, they give you 32 cans. Then they say, okay, then next one 26, next one 20. Then they ask you how many rows you will have, how many total cans do you need, so they can provide for you, right? You better know how to do the numbers. So if it's 32 first, 26, 20, what do you think? Each one will be what? Minus 6, right? Will be 32, 26, 20. What's the next? Minus 6 will be 14, right? Next one will be what? Minus 6 will be 8. Is that right? Next one will be what? Minus 6 will be 2. Then you cannot do it anymore. So you can only have what? Like 1, 2, 3, 4, 5, 6 rows total, right? So your triangle actually is much smaller like that. Then how many total rows do you need? Okay, so you can just do that, then find out the fifth row would be what? A can, right? Then how many total do you need? That means total how many rows you have. You do that, then you find out how many rows you can have. You have 6 rows, right? Then how many total cans do you need? So you need to find the sum at 6 for all those, right? So let's write it down. We want to find out at 6. What's your A1? A1 is 32, right? So what's your D? That's your D, negative 6. What's your N? N is 6, right? A6 will be what? That's 2. We know that. So what's S6? Will be first formula. N divided by 2, A1 plus AN, right? N is 6, so 6 over 2. A1 is 32 plus AN is what? A6, right? It's 2. So we do that. Then we figure out total you need what? 102 cans. So how many cans in the top row? That will be 2 cans, okay? 2 cans in the top row, right? That's how you look at it. Are we good? Think about it, what we are doing. So far, still simple, but however, when you learn next section, you will have more formulas, more different things. You will get confused. Okay? So make sure you are okay so far. Then we go for next one. Good? So this will cover our section 12.2.